This example comes out of section 5.3, the tangent function. This first bit comes out of just defining what tangent is. We know from previous lessons that tangent theta is equal to sine theta over cos theta. It's one of the first things on the formula sheet related to trigonometry, and we've used it even a couple of times. We also know from previous courses, even from our SOHCAHTOA business, that tangent within a right angle triangle is equal to opposite over adjacent. If we picture a unit circle, again remembering that the radius of the unit circle is 1, we've drawn angles inside this unit circle, so I'll just draw an angle inside the unit circle. We know that the coordinates of this point here are x comma y, and not only are they x, y, they're cos theta, sine theta, which the unit circle has allowed us, with its radius of 1, allowed us to define angles and cosine and theta of angles, cosine theta and sine theta of angles in different ways. They don't just always have to fit inside a right angle triangle. It still does agree with our SOHCAHTOA business, and this is also where we can realize that tan theta in this particular triangle would be y over x, which we actually know that also to be sine theta over cos theta. So more just confirmation of something we already know. Now, extending the definition a little bit, the word tangent actually comes from a word just meaning to touch, and when you draw the tangent to a curve, you can draw a line that just touches the curve in one particular spot. So a parabola or some other curve, you can touch it in some spot. So if I extend this definition from the unit circle further and redraw my angle here, if I draw a tangent line at this particular spot at x equals 1, it just touches my circle in this one location. If I extend my terminal arm to this point, the point here is 1 comma something. Now it turns out that that something is not as random as you might seem. It turns out that that coordinate is actually tan theta. We can prove that if we look at the smaller triangle and the larger triangle that I've drawn there. They actually turn out to be similar triangles. They both have theta, they both have a right angle in them, which means they must have all three angles the same. This first one has the radius of the unit circle, which is 1, one side which is sine theta, and one side which is cos theta. We know that this bottom side of the larger triangle is 1, because that's where we decide to draw that tangent line. And this side, just by setting up similar triangles, turns out that it has to be tan theta, because sine theta over cos theta equals tan theta over 1. So another way of looking at tangent theta by its definition and how it relates to the unit circle. Turns out that it doesn't have to be a first quadrant angle for this to be true. We can draw a second quadrant angle and have our theta here, but our tangent line stays in the same place, and the coordinate that we'll look at, 1 comma tan theta, still is where it touches, where you extend the terminal arm of your angle, where it touches that tangent line. Turns out in this case the tangent would be negative, something we also can confirm, something we knew from our cast rule, that angles that are in quadrants 1 and 3 have positive values for tan, and angles that are in quadrants 2 and 4 will have negative values for tan. So a little bit about the definition of tangent.